So what we have here is a projectile being launched off a 12-meter high cliff with the speed of 19 meters per second. It is launched horizontally into the air. And it's going to follow a trajectory. The path that a projectile takes is parabolic. It's going to follow a trajectory, something like that. And we want to figure out the time it takes to fall, so the time is in the air, and the distance it lands relative to the base of the cliff, so that's its range, or delta x. All right, either variable is fine. All right. And for the AP class, you're going to also find the velocity with which it strikes the ground. So, in the y-axis, to find the time, that's solved in the y-axis. The time it takes to fall is the exact same time it would take if you dropped it 12 meters, because the initial velocity in the y-axis is 0. What is meant by that is that when this thing is launched into the air, initially it has no up and down motion. It only has horizontal motion. It has no up and down motion. That's what that number means. And then in the vertical axis, the only acceleration is negative 9.8 meters per second squared. And so we say that the acceleration in the y-axis is negative g, negative 9.8 meters per second squared. We are ignoring air resistance as we do in all of these problems. So we also know that it falls 12 meters vertically. So delta y is negative 12 meters. The variable we're looking for is time. And so the equation that matches these is delta y equals v sub 0 y times t plus 1/2 a t squared. Notice my subscripts because I'm in the y-axis. Now you can put in your numbers and solve, or you can solve and then put in your numbers. This is negative 12. This is 0. Remember, 0 times t is 0, so that goes away altogether. Plus 1/2 times negative g, which is negative 9.8. Negative 9.8 t squared. You solve for t squared, your negative signs are going to cancel. You never should end up with a negative under the radical. And that comes out to be 1.56 seconds. So it's in the air for 1.56 seconds. Now to find the range, the delta x, how far away horizontally it lands, well, it's traveling horizontally at 19 meters per second. And since there's no air resistance, there's no acceleration, there's no speeding up or slowing down horizontally in the right-left axis. That means that for every second it's in the air, it travels 19 meters. Well, it's in the air for about 1.5 seconds, so you can kind of figure this out. It's going to be about 19, it's going to be around 30 or so meters. Just knowing that every second is in the air is going over 19 meters. 19 meters, and then keep going along. So, x-axis. The range, or delta x if you prefer. Well, you only have one equation for this, and that is the fact that delta x equals v sub 0 x times t. You have plus 1/2 ax t squared, but there's no acceleration in the x-axis, and so that's 0. So this equals 19 times 1.56, which equals 30 meters, as a matter of fact. So that's the answer to part B. For the honors class, stop right there. For the AP class, you need to find, for part C, you need to find the final velocity. That includes the final speed and the final angle. And so draw a vector diagram of the final conditions. We're looking for the speed right here, all right? It's going down at an angle. Well, that is comprised of its final horizontal velocity and its final vertical velocity. And then what we're looking for is that value v and the corresponding angle, because we can express it in terms of how fast it's traveling, which is represented by the length of that arrow, and then the angle that it hits the ground. Well, we need to know these two numbers. Well, Vx we already know because it never changes. Vx is 19. Remember that it's traveling horizontally at 19 meters per second, and it's not going to speed up nor slow down from that. Vy, well, we can calculate that because we know its acceleration and its initial velocity in the y-axis. So this is going to be its acceleration times time plus its initial velocity in the y-axis. Well, that's negative 9.8 times 1.56 plus 0. And that comes out to be negative 15.3 meters per second. And what this means is that when it hits the ground, it is traveling over at 19 meters per second, and it's falling at 15.3 meters per second. Now, using Pythagorean Theorem, we can figure out the hypotenuse of the right triangle. So we know that v equals the square root of 19 squared. And so the square root of these two added, the squares added together, as you know, plus negative 15.3 squared. Again, Pythagorean Theorem, and c squared equals a squared plus b squared. And that came out to be, let me see here, I'm trying to read my writing. It looks like it's 24.4 meters per second. So that's how fast it hits the ground, but you also need to know the angle to precisely describe this vector. And I use tangent. You can use a cosine or sine, but I use tangent. The tangent of theta is opposite over adjacent. And so the arctangent of theta, which you write as that, is opposite, so tan to the negative 1 of opposite over adjacent. So in this case, it's negative 15.3 all over the adjacent side of 19. Be sure that you're in degree mode when you do this. And that comes out to be negative 39 degrees. So this thing hits the ground, traveling at 24.4 meters per second, angled down at 39 degrees below the horizontal, down that way, measured to the horizontal. Okay, that angle right there.